Picture this. You're looking up at the night sky, admiring the gentle glow of the Milky Way stretching across the darkness. It seems so peaceful, so serene. But hidden at the very heart of our galaxy lurks something that would make your imagination run wild. A cosmic monster so massive that it weighs as much as 4 million of our suns, yet compressed into a space smaller than our solar system. This isn't science fiction. This is Sagittarius A star, the supermassive black hole that sits at the center of our home galaxy. And here's the mind-bending part. It's not just sitting there doing nothing. It's actually conducting an invisible orchestra, controlling the very fate of hundreds of billions of stars, including our own sun. For the longest time, astronomers thought black holes were just cosmic vacuum cleaners, mindlessly devouring everything in their path. But as we peered deeper into space with increasingly powerful telescopes, we discovered something absolutely extraordinary. These gravitational giants aren't just destroyers. They're architects, sculptors, and gardeners of the cosmos. Think about it this way. Imagine you're a master chef in the world's most exclusive kitchen. You don't just throw ingredients together randomly. You carefully control the heat, the timing, the portions. That's exactly what supermassive black holes do with galaxies. They regulate the cosmic recipe for star formation. When a supermassive black hole decides to have dinner, which happens when gas and dust spiral into its gravitational embrace, something magical occurs. The material doesn't just disappear quietly into the void. Instead, it creates one of the most spectacular light shows in the universe. As matter accelerates to incredible speeds before crossing the point of no return, it heats up to temperatures that would make the core of our sun feel like a cool summer breeze. This superheated material blazes brighter than entire galaxies, creating what we call an active galactic nucleus. But here's where the story gets really interesting. All that energy doesn't just shine harmlessly into space. It creates powerful jets of particles that shoot out from the black hole's poles at nearly the speed of light, traveling for hundreds of thousands of light years. These cosmic blowtorches have the power to heat up all the gas in a galaxy to such extreme temperatures that it can no longer collapse to form new stars. It's like the black hole is saying, "Okay, that's enough star formation for now. Time to take a break." And the galaxy listens, sometimes for billions of years. Andrea Ghez, who won the Nobel Prize in Physics in 2020 for her groundbreaking work studying the black hole at our galaxy's center, once described these objects as invisible architects. They sculpt their environment in ways we're still trying to understand. Her team spent decades tracking individual stars as they danced around our galaxy's central black hole, moving so fast that they completed orbits in just 16 years, instead of the hundreds of millions of years it takes our sun. But here's where the story becomes even more fascinating. Astronomers have discovered something that seems almost too perfect to be coincidence. The size of a galaxy's central black hole is directly related to the size of the galaxy itself. Bigger galaxies have bigger black holes. Smaller galaxies have smaller black holes. It's as if they grew up together, like cosmic siblings. This relationship puzzled scientists for years. Did the galaxy grow first and then feed its black hole? Or did the black hole somehow control how big its host galaxy could become? Recent computer simulations suggest it might be the latter. The black hole acts like a cosmic thermostat, turning star formation on and off to keep its galaxy at just the right size. Imagine trying to fill a bathtub, but every time the water level gets too high, a powerful drain opens up to let some water out. That's essentially what supermassive black holes do with their galaxies. They allow star formation to proceed until the galaxy reaches a certain size. Then they unleash their energy to prevent further growth. This cosmic balancing act has profound implications for life in the universe. Stars are the furnaces where all the heavy elements necessary for planets and life are forged. Carbon, oxygen, iron, gold, all of these elements were cooked up in the nuclear hearts of stars. If black holes control where and when stars form, they indirectly control where life might have a chance to emerge. Consider this sobering thought. There are galaxies out there that we call red and dead. These are massive elliptical galaxies that stopped forming new stars billions of years ago. Their supermassive black holes essentially sterilized them, preventing any new stellar nurseries from igniting. In these cosmic ghost towns, ancient red stars slowly fade away and no new ones take their place. But the story isn't all doom and gloom. In many galaxies, including our own, there's a delicate dance between creation and destruction. The black hole occasionally takes a nap, allowing new waves of star formation. Then it wakes up, has another feeding frenzy, and puts the brakes on again. This cosmic breathing keeps galaxies alive and vibrant for billions of years. Scientists using the James Webb Space Telescope have recently discovered supermassive black holes that existed when the universe was just a cosmic infant, less than 1 billion years old. These ancient giants challenge our understanding of how such massive objects could form so quickly after the Big Bang. It's like finding a fully grown oak tree in a garden that was planted just last week. Some theories suggest these primordial black holes might have formed directly from the collapse of massive gas clouds in the early universe, skipping the usual step of first becoming a star. Others propose they grew from smaller seed black holes by feeding voraciously in the dense, chaotic environment of the young cosmos. As we look toward the future, astronomers are developing new ways to study these cosmic relationships. The Event Horizon Telescope, which gave us our first direct image of a black hole's shadow, continues to peer into the hearts of distant galaxies. Future space telescopes will be able to watch black holes and their host galaxies evolve over cosmic time. Perhaps the most humbling realization is that our very existence might depend on this cosmic dance. The supermassive black hole at the center of the Milky Way has been relatively quiet during the era when our solar system formed and life emerged on Earth. But it won't stay quiet forever. Astronomical observations show that in about 4 billion years, our galaxy will collide with the nearby Andromeda galaxy, potentially awakening both galaxies' central black holes. Will this cosmic collision spell doom for life in our corner of the universe? Or will it trigger a new era of star formation and cosmic evolution? The answer lies in understanding the intricate relationship between these gravitational giants and the galaxies they call home. What we do know is that supermassive black holes aren't just cosmic monsters lurking in the darkness. They're fundamental players in the story of how our universe evolved from a hot, dense soup of particles into the rich tapestry of galaxies, stars, and planets we see today. They remind us that even in the apparent chaos of the cosmos, there are hidden patterns and relationships that connect the smallest scales to the largest. The next time you look up at the night sky, remember that you're seeing the result of this cosmic choreography. Every star, every galaxy, every planet has been shaped by the invisible hand of gravity and the awesome power of black holes. In the grand theater of the universe, these dark giants are both the directors and the main characters, orchestrating a cosmic drama that has been unfolding for nearly 14 billion years. And we're just beginning to understand our role in this magnificent cosmic story. Let me tell you about the cosmic giants hiding in plain sight. Supermassive black holes. Picture this. If our entire planet Earth collapsed into a black hole, don't worry, it won't. It would shrink smaller than a marble in your hand. Now imagine something billions of times heavier than our sun, lurking at the center of galaxies. These aren't your average black holes formed by dying stars. These are ancient titans that might have grown alongside the first galaxies themselves. What blows my mind? Astronomers found one of these cosmic behemoths that's over 13 billion years old. That means it existed when the universe was just a toddler, barely 700 million years old. It's like finding a skyscraper in the middle of a prehistoric forest, completely rewriting our understanding of how cosmic structures form. Now you might wonder, could these gravitational monsters swallow entire galaxies? Here's the twist. Despite their fearsome reputation, supermassive black holes are surprisingly picky eaters. Our Milky Way's own Sagittarius A, that's the black hole at our galaxy's center, currently consumes about one star every 100,000 years. Even at their most active, these black holes only devour material in their immediate vicinity. The real power lies not in their appetite, but in their ability to shape entire galaxies through colossal energy bursts that can either spark star formation or snuff it out completely. The mystery deepens when we realize these black holes and their host galaxies grow in perfect sync, like cosmic dance partners. A galaxy's size perfectly predicts its black hole's mass, but scientists still debate who leads this intricate waltz. Did galaxies form first and nurture their black holes? Or did the black holes act as seeds around which galaxies blossomed? New telescope data suggests it might be a bit of both, a give-and-take relationship spanning billions of years. Let me pull back the curtain on one of space's greatest plot twists. Supermassive black holes aren't just chaotic devourers, they're masterful conductors in a galactic symphony. Remember how we talked about their cosmic dance with galaxies? Well, here's where the rhythm gets wild. These gravitational beasts have a secret superpower. They can literally control a galaxy's fate with celestial, tough love. When a black hole feasts on cosmic gas and dust, it doesn't just swallow quietly. It belches out energy jets so ferocious they could cross entire galaxies, heating interstellar gas to millions of degrees. Imagine a chef blasting a flambe torch across a kitchen, except here, the kitchen is a galaxy, and the heat decides whether new stars get born or not. If the black hole cooks the gas too much, star formation grinds to a halt. But sometimes, they're gentle nurturers. In the Phoenix cluster, a galaxy group 3 billion light-years away, scientists spotted a black hole doing something extraordinary. Its jets acted like cosmic sprinklers, creating shock waves that compressed gas clouds into stellar nurseries. For every star it destroyed in its feeding frenzy, it indirectly sparked the birth of hundreds more. It's like a gardener who prunes some plants to help others flourish. Nobel laureate Dr. Andrea Ghez, who helped prove these black holes exist in our own galaxy, puts it beautifully. They're invisible architects, shaping spaces we're only beginning to map. Her work revealed how our Milky Way's central black hole, Sagittarius AB, whips surrounding stars into hyperspeed orbits, some hurtling around it at 8 million miles per hour. Yet despite this chaos, it maintains a delicate balance, never letting stars spiral too close to its deadly grip. The real mind-bender? This dance has been ongoing for over 13 billion years. Ancient light from quasars, supermassive black holes in their youth, shows they were already pulling these cosmic strings when the universe was less than 1 billion years old. How did they grow so powerful so fast? Did they mold galaxies, or did galaxies mold them? Every new telescope peering into the deep cosmos adds another layer to this mystery. So next time you gaze at the Milky Way's shimmering band, remember, hidden in its heart lies a maestro directing an epic ballet of stars, gas, and time itself. A reminder that even in darkness, there's creation. Makes you wonder, in this grand cosmic game, are we mere spectators or part of the choreography? Here's the cosmic puzzle that keeps astronomers up at night. Galaxies and their supermassive black holes grow in perfect lockstep, like synchronized swimmers across billions of light years. A giant galaxy cradles a giant black hole, while smaller galaxies host lighter ones. But who's leading this cosmic tango? Let me take you inside the debate. Imagine a black hole as a cosmic thermostat. When it feasts on gas, it doesn't just eat quietly. It blasts out winds powerful enough to push star-forming gas out of the galaxy. These winds act like a galactic off-switch, heating interstellar gas so intensely that new stars can't form. But here's the twist. This destructive force also creates balance. Without it, galaxies might burn through their fuel too fast, collapsing into unstable monsters. Recent simulations reveal a delicate dance. When a black hole grows too massive too quickly, its ferocious winds starve the galaxy of star-making material, slowing both their growth. Conversely, if the black hole lags behind, abundant gas lets it feast and catch up. It's a self-correcting system, nature's way of maintaining cosmic order. In 2024, astronomers spotted something extraordinary using the ALMA telescope. A supermassive black hole in galaxy ESO 320 G030 was spinning out magnetic winds, behaving just like newborn stars do. These spiraling gusts funnel gas toward the black hole while regulating its growth, proving black holes and stars share growth strategies just on vastly different scales. For years, scientists argued, do galaxies shape their black holes, or vice versa? The answer might be both. When galaxies collide, their merging gas feeds black holes and triggers star birth simultaneously, but black holes ultimately call the shots. Their energy bursts can halt star formation galaxy-wide, essentially freezing a galaxy's development in time. Consider the Milky Way's Sagittarius A. Though 4 million times the Sun's mass, it's relatively quiet. Yet, in its youth, it likely orchestrated our galaxy's structure through explosive growth phases. Simulations show that without such black hole tantrums, galaxies would either become bloated giants or fizzle out too soon. This partnership, half harmony, half struggle, has shaped the universe since its infancy. As Nobel laureate Andrea Ghez once observed, black holes are the invisible architects of cosmic structure, sculpting galaxies through forces we're only beginning to map. Next time you stargaze, remember, every twinkling speck holds a hidden conductor, balancing creation and destruction in an eternal gravitational ballet. Loving these cosmic revelations? Dive deeper into the universe's wonders by subscribing to Exploring the Universe. We're just getting started. All right, imagine we're sitting under a starry night, looking up and wondering about our place in this vast universe. Now, let me tell you a story that starts at the very heart of almost every galaxy out there, including our own Milky Way. Hidden in the darkness, there's a cosmic giant, a supermassive black hole. Not just any black hole, but something millions or even billions of times heavier than our sun. And here's the twist. These black holes are not just cosmic vacuum cleaners. They might actually decide where stars are born, and maybe even where life can take root. Picture this. When a supermassive black hole is hungry, it gobbles up gas and dust swirling around it. But as it feeds, it spits out enormous jets of energy, so powerful that they can heat up the gas in the galaxy. This hot gas can't cool down enough to form new stars. It's almost like the black hole is flipping a cosmic switch, turning off the star-making machine. Galaxies where this happens are sometimes called dead galaxies, because no new stars are born there anymore. Now here comes the big question. If black holes can control where stars are born, are they also deciding where life can begin? After all, life as we know it needs stars like our sun, to provide warmth and light. If a galaxy's black hole has shut down star formation, that galaxy might become a cosmic desert, with fewer chances for planets and life to emerge. It's a bit like a gardener who decides when and where to plant seeds, and when to let the garden rest. But it gets even more interesting. Some scientists think that black holes are actually necessary for galaxies to grow and evolve. Without them, galaxies might get too crowded with stars, or never form the beautiful spiral shapes we see through telescopes. So, in a strange way, black holes might be both creators and destroyers, helping life get started in some places, while shutting it down in others. Now let's bring this story home to our own galaxy, the Milky Way. At its center lies a supermassive black hole called Sagittarius A. Right now it's pretty quiet, just gently pulling in bits of gas here and there. But what if one day it wakes up and starts feeding more greedily? Could it switch off our galaxy, stopping new stars from forming? Would that mean the end of new worlds, and maybe even the end of new life? It's a haunting thought, but also kind of beautiful. The universe is full of these delicate balances: creation and destruction, darkness and light. Black holes, once thought to be just monsters lurking in the shadows, might actually be the cosmic artists shaping the fate of galaxies and the possibilities for life. So next time you look up at the stars, remember, somewhere out there, a black hole might be deciding the future of an entire galaxy. And maybe, just maybe, it's also shaping the story of life itself. You know, when we think about black holes, it's easy to imagine them as these terrifying cosmic monsters, swallowing everything in sight and leaving nothing behind. But the truth is far more fascinating and, dare I say, beautiful. Supermassive black holes are not just destructive forces. They are essential pieces in the grand puzzle of how the universe evolves. They quietly shape the fate of galaxies, guiding the birth and death of stars, and maybe even influencing where life can flourish. It's like discovering that the darkest corners of the universe hold a hidden order, a cosmic rhythm we're only beginning to understand. These black holes remind us that even in the vast darkness, there is a mysterious balance at work, an invisible hand molding everything around us. They are both creators and destroyers, sculptors of the cosmos, showing us that darkness and light are deeply connected. So next time you gaze up at the night sky, think about these incredible giants at the heart of galaxies. They are not just distant objects. They are part of the story of everything we know including ourselves. If you enjoyed this journey through the universe, don't forget to subscribe to the channel Exploring the Universe. Hit the little bell so you won't miss any new adventures. Give the video a thumbs up if it sparked your curiosity, and share it with friends who love to explore the mysteries of the cosmos. After all, the universe is a story best shared together.